Alright, this is the Algebra 1-2 Fall Final Review 2011. This is the 3-day review, and I'm going to at least try to do a lot of the day 1 problems, and if I have time, I'm going to try to go through all 50. Okay? So first question, the number of children in a family, we're trying to look for what makes sense. The reason why this is D is because the number of people in your family could be a whole number, so could be 0, 1, 2, 3, etc., all the way up. It doesn't make any sense to have negative members of your family, so integers wouldn't count, or fractional members of your family, or decimals that never end with irrational numbers. So that's why it definitely makes sense to have that be whole numbers. Radical 2 is an irrational number. You've got to know that. It's a decimal that never ends, so that's why we classify it as irrational. How many apples were eaten at a picnic? Well, it is possible to eat, 2.5 apples, some fraction of apples, so that's okay that's rational numbers. The number of numbers, the numbers keep growing, so we can't really count them all, so we're going to say that there are an infinite number of numbers. Infinite means that it's not countable. It just keeps going. Finite means it's a definite number, like 100, 200, even a gigantic number is still finite. You can count it. The number of states in the U.S., definitely finite, 50. Number of digits in radical 3. Again, radical 3 is an irrational number. It's a decimal that never ends, and so that's why we classify it as an infinite set of numbers that we cannot count. Evaluate the expression. This is using the order of operations. So you remember your please excuse my dear Aunt Sally. And so for this problem, what you want to do is you don't have any parentheses, but you do have the exponent, so you kind of need to do that. So I would go 3 plus 6 divided by 3, and technically you're doing the 4 squared first, so 16. And then the next thing to do would be to do the multiplication and division, so that would be the division there. So 3 plus 6 divided by 3, of course, is 2. And now I'm ready to do the addition and subtraction. So I would do this 3 plus 2, so that would be 5 minus 16. So that looks like that would be negative 11. So that's why we say that one's B. Do a similar deal for the others. Please excuse my dear Aunt Sally is that one that most people use. Name the property. So you have to look at the left side of the equation and the right side of the equation and kind of see what the change is. When you look at this one, you can tell that really what's happened is the B has been distributed because it's C times B and then the A times the B, and that's the distributive property. Okay. And when you look at day 2, it looks like it's 3xy, 3xy. They're still in the same order, but if you look at the parentheses, they have changed. So anytime you change the parentheses and everything else stays the same, and that's why that's the associative property. If you look at the day 3, 5a and 3b, those have actually changed order. So when you change the order, we call that the commutative property that allows you to do that and still have a true equation. This one is on the final a couple of times, and this is distance equals rate times time, just a good real-world equation that's used a lot. So Susie drives 6 hours, that's the time, and we're going 60 miles an hour to 70 miles an hour, somewhere in that range, at least Susie's driving. So real easy to figure out. If you want, you can plug in a number in between 60 and 70, like maybe 70 or 65. And so for the rate, you could put in, 65. And then you can multiply that by the number of hours, which is 6. And so 65 times 6 is 390. Actually, that's not good. Well, wait a second. 360 420. Well, yeah, so this one, it says that she drove, it could be 420 because if she went, so it's not the greatest question in the world. So 70 miles an hour, if she goes for 6 hours, that's 420 miles. That could work, so we could go with that. But if I did 65 times 6, then I would get 390 miles. So I would look for an answer that's pretty close to that. Okay. The other ones are so far off that they don't really make sense. But all you're going to use for that one is distance equals rate times time. Okay? The next one, find the value. What you want to do here is take the absolute value, or you want to actually do all the work inside the bars first and then take the absolute value. So 12 minus 5 is 7. And then you want to take the absolute value of that. So that's going to be 7. So you're going to get 7 minus, and then go ahead and take the absolute value of this. So that's going to come out of the absolute value bars as just a 3. So that's going to be 7 minus 3, which is just positive 4. So that's why we say that one is C. And then real similar deal for the rest of them. But just make sure you do the work on the inside of the bars first, and then take the absolute value of it. Kind of treat it like you would, almost like parentheses. Do all that work inside. Number 8, you want to solve for R. So you're trying to get the R by itself. Do whatever you need to do to get rid of all the other things. So for this day 1 I'm going to do, you just have to get rid of the P and the T. So if you just divide both sides by PT, because those are the two things that are being multiplied by the R. So we divide by that, and that will be enough. Then the R will be all by itself. And you can see that those would cancel out, and you just have the R by itself. So on the left, it'd be I divided by PT equals the R. Okay? Maybe one other one here. If I was doing day 3, I'd try to get the R by itself. So I would probably add the 2P to both sides. And so that would be 3R all by itself. And this would cancel out. And that would be T plus 2P, and then I would divide by 3. So R would be by itself, and so I'd be looking for an answer like this, which is T plus 2P divided by 3, and that's why that one is the D. Number 9, you just want to solve for Q. So you distribute. And this is one that would be, commonly missed. So what we'd have is I'm just doing day 1. So I'd have 5Q, and then I would distribute this. So that would be minus, and that would be 12Q. And then I also have to distribute this negative sign. So that's going to be negative 3 times a positive 2. So that's negative 6, and that's greater than or equal to 6. And now I need to combine like terms. And I notice that these are on the same side of the inequality, so I just add and subtract them like normal. So 5Q minus 12Q is a minus 7Q. Minus 6 is greater than or equal to 6. Then I need to add 6 to both sides. So I'm going to go ahead and add 6. And that's going to cancel this out. So that would be negative 7Q is greater than or equal to 12. And then the last step would be to divide by negative 7. And when I divide by negative 7, I do have to remember that when you multiply or divide by negative, you have to reverse the inequality, and then it's going to be negative 12 sevenths. So Q is less than or equal to negative 12 sevenths. So that's why it's that one. Number 10, which one of these is or 9, which one of these is a function? We're trying to use the vertical line test. Remember, it's a good test to see whether something's a function or not. So we should be able to take any vertical line and run it through the entire graph and never touch the graph more than once, never intersect the graph more than once. So that's why it's this one, because all these vertical lines that I run through the graph, if you took your pencil or something, you always touch the graph just once for every one of these. You can tell this one's not. It only has to fail once for it to not be a function. So it fails right there, done. It's not a function. so not a function. This one fails like right here, so already not a function. So the only one that is A. Okay. Let's see. Yeah, so we should be good for that one. 11, domain and range. This is probably about the easiest question. So domain, they're going to be your x's if you're dealing with x's and y's. The range is the y's. So let's look and see. For day 1, the domain is 3, 2, negative 1. So we just look for that. We can see that that's why it's 3, 2, negative 1 here. And then the y's are negative 2, 1, and 4. So that's that answer. Okay. Which one represents the data? I mean, you're given a data table and you're supposed to write an equation that goes with it. I mean, technically, the skill we wanted you to have was to be able to take 2 points and figure out the slope and everything. So you would take a couple points, figure out the slope. The truth is right now that we're, now in the test mode, we can actually work backwards a little bit. And so you can use the equations and you can try to figure out which one of these sets of numbers works for these equations. That's just a wise test-taking strategy. So let's say you try that first one, x plus y equals 5. Then you want to try to see if these numbers work. So let's try x plus y equals 5. You take each of these numbers and plug them in for x and y. So 2 plus 3, that equals 5, check. Then you could do 4 plus 1 equals 5, check. And then 6 plus a negative 1, does that really equal 5? Check. And so you can kind of work backwards on this one. It'll save you a little bit of time to get this, get this particular problem right on the final. We may have another one where I actually work it out, find the slope and all that. Okay, 13. What's the slope of the line passing through these 2 points? So first you want to figure out you want to use the slope equation. And so that slope equals y2 minus y1 over x sub 2 minus x sub 1. And so if you label your points, that would be x1, y1, x sub 2, y sub 2. And so your slope will be 4 minus a negative 1 over 3 minus a negative 2. So that means this is actually going to be a 5 on the top because it's 4 minus minus, so it's 4 plus. And then the bottom is actually 5 as well, so that's 1. I got a slope of 1, and I messed it up. So let me see. 4 minus a negative 1, 3 minus a negative 2. I got 1, so I must have looked at the key wrong. So hold on 1 second. So number 12 should be B. Let's see, 4 minus a negative 1. Looks like that's right. 3 minus a negative 2. Yeah, I think that's right. So it looks like I might have the wrong answer for that one. So 12C. All right. I may have to do the other days really quickly too now. So day 2, that'd be 5 minus 2 over negative 1 minus 0. So that would be 3 over negative 1, which equals negative 3. That one says A, so that one's good. Day 3 should be 6 minus 1 over negative 2 minus 3. 5 over negative 5, so that one's negative 1. So that one's good. But it looks like that day 1 is actually C. Okay? All right. Next one. Number 13, which one is the graph? So you've got to know slope-intercept form really well. So if you look at day 1, the y-intercept, we're talking y equals mx plus b here. So the y-intercept is negative 4, so just look for the graph that has negative 4 where it crosses the y-axis, so right here. And then the slope, you can tell, is 2, or 2 over 1. So you go up 2 over 1. Makes sense if that's the line. Which of these is in slope-intercept form? So here's the full method. So first you want to find the slope, so just what we did before. So we'd have 4 minus 1, so this is your These are your y's, so 4 minus 1. And then on the bottom, you could do 3 minus 2. So it looks like we have a slope of 3 over 1, or just 3. And then choose one of those 2 points that you want to use. So we're going to use the point 2, 1, and we're going to use the slope of 3. Start off with y equals mx plus b. This is one way to do it. And so we plug in a 1 for the y, plug in a 3 for the slope, 2 for the x, and then try to figure out the b. So we have 1 equals 6 plus b, and then subtract 6. So b will equal, if we subtract 6, that would be negative 5. So now we have the slope, and we have the b. So our equation is y equals 3x minus 5. So that's why it's A. Oh, that's me. Okay. So the slope and the y-intercept. So it's hard to tell the slope and the y-intercept without putting it into slope-intercept form. So we need to do a little bit of work on this day 1. So let's go ahead and do a little work on this one to get it into good slope-intercept form. So I would subtract 3x. So that would be 2y equals negative 3x plus 12. And then divide by 2. So y equals negative 3 over 2x plus, and that would be 6. So I'd look for that answer. Oh, well, actually, so now the slope, I can tell what it is real quickly. The slope is negative 3 halves. It's that right there, slope. And then the y-intercept is that, so it's 6. So that's why it's this one. The x-intercept and the y-intercept, this is, let me just show you day 1. If I'm looking for the x-intercept, then what I do is I put a 0 in for the y. So I set y equal to 0 and solve for x. So for this one, if I set y equal to 0, most people will show you kind of like the cover-up method. So you could like cover this up, and so then you'd have, or make that equal to 0, which basically covers it up. And so then you'd be left with 4x. Well, actually, let me just show all the work. So 4x plus 3 times 0 equals 12. And then that becomes 0, so then you'd have 4x equals 12, so x equals 3. That's your x-intercept. Your y-intercept means that you're going to set x equal to 0, and you're going to solve for y. So if you set x equal to 0, then it'd be 4 times 0 plus 3y equals 12. That becomes 0, so this would be 3y equals 12. So your y-intercept would be 4 when you divide. So you look for that. If it's an x-intercept, then it's always going to be 3, and then it's going to be 0 for the y. And then if it's a y-intercept, then the x-coordinate is going to be 0, so it's 0, 4. And that makes sense, you know, on your graph. If it's an x-intercept, that means it crosses the x-axis, and the y-coordinate is always going to be 0, 1, 2, 3, boom, right there. Okay. And then the y-intercept has an x-coordinate that's 0. So that's why that one should make sense, that it's this one, B. Match the graph. Inequalities are the same thing as lines, but you've got to do a little shading. So this one has a y-intercept of 2. So I would look for a graph that has a y-intercept of 2. So it looks like it would be this one. The slope is whatever's in front of the x, so there's nothing there, so it's a 1. So I'd go up 1, over 1. And then it doesn't have a bar underneath it, so it's a dotted boundary. So remember that. If it doesn't have a bar, it's dotted, and if it does have a bar underneath it, it's solid. And so that's why it's C. Oh, and we got a shade. So good way to do it is probably to do a nice test point. So you can use 0, 0 as long as 0, 0 is not on the line itself, the boundary line. So plug 0, 0 into the original inequality. So if I do that, I put a 0 here and a 0 here. So that would be 0 is greater than 0 plus 2. So 0 is greater than 2. Is that true? 0 bigger than 2? No, that's false. So that means that 0, 0 as a test point doesn't work. So I don't shade the side that has that in it. So then I shade the other side of the boundary line. Correlation, let's see, part B, or day 1, has a negative correlation. As x gets bigger, looks like the y values are actually getting smaller, and so it's negative correlation. Positive correlation, and then this one doesn't look like they have any sort of a relationship. They're all over the place, so we say no correlation. Algorithm. An algorithm is a procedure. Okay, what are the series of steps so that you could find the slope of the line that connects those 2 points? So we know that we subtract the y's over the x's, so we would look for something that says that and that the calculations are right. So that's why -1 minus the 3. So this one does make sense. -1 minus 3, and then on the bottom 4 minus 2, which is what this one says. Make sure the calculations are right. -1 minus 3 is -4. 4 minus 2 is 2. When you divide those, boom, that is the right answer. Okay, which of these is correct line of best fit? So day 1, let's see. This looks a little bit confusing, telling what in the world is going on with these points. Let's see. Oh, out of the, let's see. I don't even know. Oh, okay. So these are the 3 lines that you're checking out, and you're seeing which one does a nice job of modeling the set of data. So it looks like this one, number 1, kind of is nice. It kind of goes through the middle of the data. Out of, I guess out of these 3 lines, which one's the best? And so you can tell that this one here is the best, number 3. That's what we're saying there. And then these are all, they're not great, 1, 2, or 3. But the one that at least does the best job maybe of the data, of modeling the data, would be this one, line 1. So I don't know if I like the way that question's set up, but that's how you work it. Use a survey. So this is kind of for day 1. It says Sean earns $25,000 per year. That'd be like about right here. You just kind of go over and look to see about how many years that would be. If you had a line of best fit, it would kind of look like that. And so just kind of estimate about how many years experience that would be to match up with $25,000. Box and whisker, which one contains 25% of the data? Remember that each whisker is 25%, and the middle, the whole box itself, is 50%. And then that means that if this is the median, then this is 25%, this is 25%, so you can answer any questions about it. So what's the range, 25% of the data? If you look at 20 to 40, that looks like it's this part of the box, so it's the lower half of the box. So that's 20 to 40 right there. That's 25% of the data. Okay. The score 40 is called that's the median. That's that little slash that's in the box somewhere. It doesn't have to be in the middle of the box, but it has to be somewhere in the box. Okay. Box and whisker, it's going to be a pretty similar question. Which range contains the lower 25% of the data? Again, that's the whisker. So that looks like it's 40 to 50. Classify each as an independent or dependent event. Okay, dependent means that when you go ahead and do it again, it actually affects it. So this would be like if you didn't replace. So this is dependent means the keywords we're going to say are without replacement. That kind of affects what happens the next time. You don't put the marbles back. So without replacement. Independent event means that you actually put whatever you took out back, so that the next time you do it, it's going to be the same probability. So that's with replacement. So 3 yellow marbles are picked from a bag of 8 blue and 8 yellow marbles without replacement. So we're not putting them back, so that's why we're going to say that it's dependent. Okay. Roll a die. Anytime you roll dice, it's going to be independent because there's not really, it's going to be the same probability, each time you roll the dice. Most likely, a die is tossed 12 times. Predict the number of outcomes that turned up. That turned up a 2. So we know that anytime you roll a die, you have a 1/6 probability of any particular number. And if you roll it 12 times, then you can just multiply that by 12. And that should help you figure out how many times any particular number would show up. So 6 can cancel with the 12, so we should expect that to happen 2 times. Okay. Each of the 6 numbers on the die, theoretically would happen 2 times if you were to toss it. If you were to toss it 12 times. What's the probability of spinning a 5? Well, we look at the spinner and make sure we know how many numbers are there. So we've got 8 numbers. It looks like there's only 1 5. So watch that closely just to make sure there's only one of those. So there's only 1 5. So there's one chance. And then the total number of outcomes is 8. So that's why we'll say the probability is 1/8 of spinning a 5. What's the probability of choosing a pie from 3 pies, 4 cakes, and 2 cookies? Well, we need to know the total outcomes. That's what goes on the bottom. So that's 3 plus 7 plus 2, so 9. And then choosing a pie, we have to know how many favorable outcomes that is. And there are 3 pies, so that would go on the top. 3 chances of picking a pie. So we reduce that, and so that would be 1/3. Stem and leaf plot. So the stem will be that first digit. So it looks like our lowest digits we have here, lowest numbers are 27 and 28. So we would look for a stem that had a 2, and then on the leaf it would have a 7 and an 8. So that's why this one works, because you can see the 7 and the 8 there. The 3 should have a 2 and a 4, so you can see that. And then the stem of a 4 should have a 2 and a 5, so you just look for that. And we look for, on day 1 at least, we look for an increase in sales from 2000 to 2002. You can tell that from 2000 to 2002 there's an increase in the sales. So the bar graph just goes up. So it's really that straightforward. And then the rest of them, I think we're all pretty good at reading basic graphs. Which one of these, day 1 I'm looking at, which one of these, A, B, or C, has defective information? Well, you want to make sure in a pie graph that at least all of them equal 100%, because it's a full circle and you need to have your 100% there every time. This one the C doesn't really make sense because it's just, a line graph's not good for this type of thing, because what is this? There's nothing here. There's no X value here. All we have is English, and so we have that percentage, but what is all this? So when you have a line graph, that means that you have to have something down here to represent, each of these points. There are an infinite number of points here on a line. So this is just not effective, not an effective graph to show this type of information. So that's why it's C. This one's a good one. It's a challenging one for most people. So we want to try to write an equation to figure out the ages of Mary and John. And we know that Mary's 5 years older than John, and the sum of their ages is 23. You have to know that a sum is adding, and you have to know that equals 23 there. So let's say that John is X. So if we let John be X, then we know that Mary is 5 years older than John. So we know that Mary would actually be John's age, but then plus 5. And if we wanted to figure out the sum of their ages, then we would just add those 2 ages together and set it equal to 23. So John is X, Mary is X plus 5, and we say that equals 23. And that's really it. We just look for the answer that represents that. So that's why it's this one. This one, the percentage, find the percent. We just want to take the numbers and multiply them together. Of means multiplication. So 42%, make sure that you make it a decimal. All percentage all percentages have to move to the left 2 spots. So 0.42 times 50. And we are able to use our calculator on this. But either way, if it was by hand, it wouldn't be a big deal. So 50 times 0.42, and that should be 21. So that one. Best estimate. So $29 for the jeans, and you're multiplying that by the sales tax, and that's a percentage again. So you just multiply it by 0.10, just moving the decimal place over 2 spots. And so that would be, let's see what we got. Best estimate, so we have to add the tax. So we're going to, let's do 29 times 0.1. And of course that will be 2.9, which is $2.90. That's just for the tax. So then we take the tax. We always have to add that to the price. So we have $29 plus $2.90 for the tax. So we add these together. So 29 plus $2.90. That would be $31.90. And so what's a good estimate? So we just look for whatever is, pretty close to that. And we can tell that that's D. It's about $32. Okay? Simplify. I'm going to do day 1, so that would be -3. Whenever I see 2 negatives like that, I would immediately make it a plus. So then it's -3 plus 14, which is actually 11. So that's D. Evaluate the expression. So we just have to plug the numbers in. X is 2 and Y is 3. So we'd have absolute value 3 times 2 minus 4 times 3, and that would equal, on the inside of the absolute value bars, that would be 6 minus 12. We're carrying the absolute value bars along. And then 6 minus 12 is -6. Still have the absolute value bars. Now we're ready to take the absolute value of that, and that would make it positive. So that would be 6. Okay? Make sure you do all the work on the inside of the bars before you ever take the absolute value of anything. Okay? It's the last thing you do. Okay, this one you just want to combine like terms. So these are all the same. They're all x's. So you just add or subtract the little coefficient in front of it together. So 5 minus 3, that's 2, minus 1 more, so that's only 1. So this is just 1x. And then we got the plus 4, so x plus 4. Just combining like terms. Solve for x. So if I do day 1, what I would do, let me just write it real quickly. You want to subtract 7, so that would get rid of that. 2x equals 14. Then divide by 2, so that would be 7. So x is 7. That one. Okay. 39, you want to make sure you distribute. So if we distribute this, I'm going to show the work just right off to the right. That would be 4x plus, and then 2 times 1, so that would be 2, equals 14. Then we would subtract 2. So 4x equals 12. And then divide by 4. So x equals 3. I think we're probably good at that. Solve for x. Same thing again. So we definitely want to make sure you know how to solve equations. So the first thing to do would be to get rid of the positive 10. So subtract 10. So 2x equals 6 minus 10. That would be -4. Divide by 2. So we got x equals -2. So that's B. 41, really good way to solve equations like this. These are proportions when you have one fraction equal to another one. I think cross-multiplying is a really good way to do it. So 6 times x, that would be 6x equals. Then we have to multiply -4 times x minus 15. we're going to have to distribute that. So we distribute this. So that's going to be negative 4x. Negative times a negative, so that's going to be plus 60. And then we want to get our x's together. So probably a good idea to add 4x. So we add 4x. So that'll cancel that out. That'll be 60. So it'll be 10x. And then divide by 10. Divide by 10. X equals 6. So 40C, yep. Okay, absolute value bars. You want to remember with absolute value bars that you've got to do two different cases. We're going to have the one answer there for you if you forget the two cases, so don't be tricked by that. So x plus 6, the first case, you just rewrite it as it is. And then the second case, you could have x plus 6. This is one way to do it. You can just change the sign on the right. And then on the left side, you just subtract 6. So we have x equals, and then we've got 4 minus 6, so that's negative 2. That's one answer. Or we've got another answer, subtract 6, so x equals negative 10. So make sure you look for both those answers, negative 2 and negative 10. So that's why it should be C. Some of your teachers I've seen maybe do a little bit different, so just follow whatever the instructions are for your teacher on this right-hand side. For Algebra 1, 2, I just go ahead and do this method, but if they have a method of making the left side doing this deal here, that's a great way to do it too. It's actually more advanced. Okay. Write an inequality for each graph. This one looks like it's right here at negative 1, and it's closed, and so it looks like all the numbers greater than or equal to negative 1. So I got to use this. I got to use this inequality because it has a bar underneath it. This one is the same thing, but it has an open circle because it doesn't include negative 1. And then this one looks like, this graph looks like it's everything except for negative 1. So that's why it's open at that spot. So that's why it's C. Solve for x. Inequalities are really, you just solve them the same way you do the equations. So just add 9. So x is greater than, looks like 18. So C. Solve for x. Okay, you got to be a little bit careful on some of these just because of the reversing of the inequality. So this is a positive 14 right now, so I'm going to subtract 14, and that'll be negative 3x is less than, and we're going to just subtract that. So 41 minus 14 is 27, and then I'm going to need to divide by negative 3. And because I'm dividing by a negative, I'm going to go ahead and reverse the inequality, make it a negative 9. So x is greater than negative 9. That's why it's B. Okay, I want to solve for x. So this one here, I would try to get the x's together. So try to go ahead and subtract 2x. That makes the most sense. So 3x minus 2x is just x, and it's less than or equal to 10. So that one is C. Okay, compound inequalities a little bit here. So looking at day 1, this is an and problem whenever they're squeezed together like that. And all you have to do is try to isolate the variable. So you got a plus 4, so just subtract 4 from all 3 parts. That would isolate the x. So x is right in the middle. Keep all the signs the same. 6 minus 4 is a positive 2, and then negative 3 minus 4 is a negative 7. So the way you read this is right from the x. X is greater than negative 7, and at the same time, x is less than 2. So we're looking for all the numbers that are in between negative 7 and 2. So I'm looking for the graph here, and it looks like it is this one. And it needs to be an open circle on both sides. It's a little detail. Neither one of these have a bar underneath them, so they're both, notice that they're both open. Okay, so don't go too quickly on this one, because you might pick this one because it looks like about the same numbers, but they're closed, and obviously we don't have that bar underneath it. So pay attention to detail. A number n decreased by 4 is 6, so we've got a number n decreased by 4 is 6. So we just look for that one. Make sure you know how to translate product of a number. You know that's multiplication. So product of a number, so that'd be 4n, and then decreased by 6 is equal to, and then 12. Okay. Number n to the 4th power, see that one, decreased by 6 is 12. Okay. Distance equals rate times time. I mentioned that shows up 2 times out of 50 here, so you got to know that. So a person travels 8 hours, 60 miles per hour. How far do they travel? So again, just real basic, just multiplying numbers together. So the rate, that's your rate, so that's 60 miles per hour. And then your time is 8 hours, so you can include your units there. If you like, I should probably put them in there. So 60 miles per hour, and then times 8 hours. And you can see it's pretty cool that the units cancel out, and so that's why we just have miles for the distance, so 480. D. Last couple, 49. What's the slope of the line perpendicular to the following? So day 1, if you have a slope of a line that's negative 4/5, you must remember that you have to reverse, you have to flip the fraction, and you have to change the sign. You have to remember both of those things when you have perpendicular lines. So we flip the fraction, and we change the sign. So it was a negative, now it's a positive. So that's why that's 5/4. Line with the, let's try this one. So if this one has a slope of 5/4, then what we'd have to do is we'd have to flip it, and we would have to change the sign. So these would be perpendicular lines. They would have these slopes. Okay? And what is this one? Line with the y-intercept of 7 and slope of 2. Well, we're just paying attention to the slope of 2. So if it has a slope of 2, then if it's perpendicular to it, right now it's 2/1. So then if it was perpendicular, then it'd be negative 1/2. We'd have to flip it and change the sign. Okay? Remember that. Parallel lines have the same exact slope. Perpendicular lines have a negative reciprocal slope or opposite reciprocal slope, however your teachers are showing you that. Okay, correct graph. You got to know how to graph some lines. So if you look at the equations over here, you have a y-intercept of 2, so you look for a graph that touches the y-axis at 2. So it looks like it's this one. And then it has a slope of 2/3, so you go up 2/3. That's why that's that graph. This one has a y-intercept of 4, so you go up to 4. Slope is negative 2/1, so you go down 2/1. That's why that's that graph. So let's see. I think that covers it. Hopefully that helps.